Okay, Ji. So this lecture that we are recording right now is basically the first and second class of what we've discussed so far for your O-level syllabus or IGCSE syllabus. So if you're going for your IGCS, the IGCSEs, it's 0478. If you go for your O-levels, it's 2210. In our case, it does not matter much because all of the content that we cover in either one is the same goes for the papers. The only difference that comes up is basically the final grade threshold that comes out. That's a bit different in your IGCSEs as compared to your O levels. One. First thing to look into is the important websites for your own learning in regards to what happens practically around us. Because technology is not something that you can memorize, it's more about what happens with technology around you. That's something that you need to learn with time and go through stuff. So these are certain important websites that are recommended to go through. So that will help you in the learning process. Next important part is your syllabus. Now, if you see this document, if you've seen it good enough, if not, this is a very important document that will help you understand what is required out of you from the examiner. So what's the examiner asking you to get done so that you can get marks and everything in that regards. Okay, so the certain important parts of this document, जिस पर मैं अभी बात करने लगा, that you as a candidate need to focus on. What are the chapters that we need to be covering? So these are paper one content, these are paper two content. Paper one content is more related to theory based stuff that you can memorize and get done, while paper two is more practical related stuff. So you need to put in a bit more logic into it, especially with chapter 7, chapter 8. This contains pseudocode, algorithm, flowchart, and everything in that regards, which is a bit technical. So yeah, this is something which is which is one major topic where students mostly struggle. Yeah, and this is one important topic because if you have a good base, ये आपको आगे A levels में भी काम आता है इंशाल्लाह. Moving on further, there's two papers that you have to prepare for. Paper one, which is a 1 hour 45-minute paper. So goes for paper two, which is then again another 1 hour 45-minute paper. We'll get into the complications of paper two because it has certain bit of complications, but general guidelines, no calculator is allowed for both papers. Both are 1 hour 45-minute papers. Both have equal weightage at this point. Chapter 1 till chapter 6, as we pointed out, are part of paper 1. Chapter 7 till chapter 10 are part of paper 2. Now, paper 2, after the 2023 syllabus update, contains a question which is a SPQ. That basically is the 15-mark question at the end that you might have seen. We'll be talking about that later in a bit more detail. So that's another important part of this syllabus document. Part 1, what do you have to study? Part 2, what are the papers that you are going to appear for in computer science? अच्छा, in regards to what you have to study, थोड़ी सी डिटेल में आता है. So for chapter 1, what are you concerned with? The examiner आपसे क्या क्या पूछेगा? So the examiner will ask you these certain topics and these certain subtopics. The book is important for sure, but something more important than the book is the syllabus document. It highlights everything you as a candidate should know in order to basically work or prepare yourself for your examination ताकि उस हिसाब से आप पेपर की तैयारी करके आए. So these are certain detailed topics and subtopics that you have to complete. This is something another important with this document. Okay. One or two more things that are important is एक और चीज जो important है जब हम pseudo code या flow chart और वो सब चीजें पढ़ेंगे. So a bit of more detail about paper one and paper two, especially the SBQ. We'll be talking about that in detail once we start pseudocode. So that's that phase. We'll skip it for now. When you study flowchart, कौन-कौन से shapes का पता होना चाहिए. Boolean logic के chapter 10 पढ़ेंगे कौन से shapes use करेंगे. Pseudocode पढ़ेंगे तो क्या चीजें किस तरह लिखनी है. All guidelines is available with this document as well. One major thing that normally I feel is an important part of every syllabus that you study, but many students don't even know this exists. It is known as command words. So, command words is basically those keywords in which the examiner is asking a certain question with a certain perspective. Like, if you get a question, define RAM, explain RAM, or describe about RAM. So, the idea is it's three questions that are different because it has three different words. Now, for me and you, it might be the same, but for the examiner, it's different because define means a different thing, describe means a different thing, explain means a different thing. So, this is something that I feel as a candidate, one thing that normally students mess up or do not take care of while reading the question, this costs them certain points or marks over it. Okay, तो ये एक छोटी सी बात है जो ध्यान में रखनी है. I don't, for sure, I don't expect you to memorize everything, but you need to at least go through it once. So when you answer questions, you clear on what you're doing. ठीक है जी. अच्छा ये एक important बात है command words. That's then again an important part of the syllabus in that regards. Okay. So that's majorly talking about syllabus. So ये screenshots डाले हैं ये भी वहीं से लिए गए. Getting on to the next part. So what we're doing right now is generally something that I say as this chapter that we're doing is something I refer to as chapter number 0, which is Introduction to Computers. So what we are going to discuss right now is what happens inside the computer. Anything and everything we study over the entire course of the syllabus will be something that I'll link back to this chapter. So I'll be discussing every small detail over here. Yeah? We'll start from the first term, computer. So everyone has heard of the term computer, and everyone has their own version of a definition of it. One thing I feel that is a easy to go term or definition is computer can be defined as a complex calculator because the goal of a computer is to calculate or process data. But the catch with that is in a computer, we use complex data representation. We will further be studying this in chapter 1.2. Data can be represented in a computer in different forms. Major ones are text, sound, and image. Hence, we say computer is a complex calculator. I hope that part is clear. Computer can be defined or further categorized into two major categories, that is the hardware or the software. So both combine together to form a computer. Can any device be a computer? Partly yes, partly no. Because a computer has a proper definition, that is, it must contain hardware and software. And then further on, hardware contains input devices, output devices, storage devices, and processor as a compulsory part. If if these four combine together to form hardware and it has a compatible software, then it can be categorized as a computer. We'll get to that shortly. So getting on to the hardware, how would you define a hardware? There are multiple definitions. Something that you've gone through since you're a kid was physical components or components that we can touch are known as hardware, while components that we cannot touch are known as the software. But better definitions would be physical components or physical equipment devices that we use are known as hardware, while the virtual components that we use or virtual elements of a computer are known as the software. A better definition is given over here. Take a minute, go through it, I'll proceed further. There are certain words described over here, I'll be talking about that, like for example, peripherals. Other than that, it talks about the internal and external hardware. Internal hardware are those that are part of a computer system within the entire, should I say, casing or structure enclosed inside. External are everything that are connected externally via the USB port. That's the USB. So generally USB refers to the universal serial bus. That's the port, okay, where we connect the device onto. So it's basically the USB port that we're talking about right now. Yeah. USB refers to the port, not the storage. There's something that we commonly say, which is wrong, कि हम USB को कहते हैं flash storage basically. So USB is not flash storage. USB is only the port through which we connect devices. उस जगह पे जहाँ पे डेटा स्टोर कर उसको पेन ड्राइव या फ्लैश ड्राइव कहते हैं, ठीक है? Getting back to a core part. So peripherals is what we're talking about. Peripherals are referred to as all external devices connected through ports are known as peripherals. That could be input or output devices, as in a keyboard, a mouse, a touchscreen, a printer, and so on and so forth. So all of these are considered as peripherals. Moving on further. So hardware contains input devices, output devices. We'll get to that shortly. Input devices, a definition that we've already heard of. Input devices gather data or they collect something from the user, and output devices show something to the user. Now, the something can be defined in a better manner. So we say input devices gather data from the user, and output devices display information or make information available to the user. Now, I've used two new words, data and information. अब तक मेरे और आपके लिए data information was the same thing. But no, they're two different terms. Why? I'll get to that in a minute. So basically, हमने कहा input devices gather data from the user. So they collect something from the user, while output devices display information or they provide something to the user. So that something is defined as data or information. The diagram you're seeing before we continue further on is how a computer works in a basic manner. So this is the basic working of a computer. According to the new syllabus update after 2023, you as a candidate might be asked to draw any diagram of something that you might have studied or something that you might have just read by. It averages from a 3 to 6 mark question that has a common place in your paper one after the new pattern update in 2023. So you have to remember certain diagrams that you study from the book, certain diagrams you'll have to create on the spot or improvise in that regards. Okay, so you have to understand it in that. The first diagram you're seeing over here is the basic working of a computer. The diagram you see below is the same thing. The only difference is input, as we just said, can be called as data because it is collecting of data from the user. And output is basically displaying information to the user. So the idea is the diagram you see at the bottom is the same in a different terminology. So how are data and information two different things, as I just said? Just to understand that better, we say data is often referred to as raw facts and figures, like these numbers. What do they represent? They could represent anything. It could be a PIN number for someone, it could be a phone number, an emergency number, or some sort of anything in the shortcut in that regard. So these are numbers, but they do not have any meaning, hence raw facts and figures. When we add process to it, or when we process the raw form, we get meaning to it. Hence, processed form of data is known as information. Like this is a pin that adds meaning, it is known as information. I hope this is clear so far. We'll continue further on. So we've talked about two major categories. Just going through the example for your understanding input devices. We have mouse, keyboard, touchscreen, microphone, so on and so forth. For output devices, we have the LCD, LED panel in that regards. We have the speaker and so on and so forth. Next category is an optional one, which is IO devices. IO devices are generally known as input-output devices. They perform both together, like your headphones. So your headphones have a speaker and a microphone, or a photocopy machine. It has a scanner on top and a printer at the bottom. Moving on further, the next category of devices, or rather, before we address further, let's go through one question so far of what we've studied. So based on what we've studied so far, USB flash drive, where we store data, would be considered as an IO device. But no, it is rather considered as a storage device. Why? Because its primary responsibility is to store data, not input out. So when we want devices which should be responsible for storing data. These are generally categorized as storage devices. Okay, just go through the definition. I'll continue further on. As a general idea, what we say is storage devices are responsible for storing data. Now, data can be temporary in nature or permanent in nature. It could be categorized as a primary storage device or a secondary storage device. We'll get to that in. So here's what happens. We generally say, just to conclude for now, because this is what we'll discuss in chapter 3 in detail. Primary storages are those without which a computer cannot function. These are normally known as the RAM and ROM. We'll get to that in a minute. Normally, we have another third memory known as cache or cache. This is also in some cases considered as a primary storage. In some cases, it's not. Yeah, we'll get to that in. Why, what, and how is something that we'll discuss in detail chapter 3. But for now, we'll get to the introduction. Then we have our data. So where do we store our data? It's stored in the secondary storage. Generally, for secondary storage, we categorize based on technology. So we have three different types of technologies. We have the magnetic technology. The example for this is the hard disk, hard drive, or the hard disk drive. Same thing, three different names. Then we have the next technology known as the solid state technology. One perfect example is the SSD drives or the SD cards, or the flash cards, and so on. Third technology is optical storage. So for optical storage, we have the CD, the DVD, the Blu-ray, and so on and so forth. So the secondary storage that we store data in are categorized based on the technologies rather than just the devices. Okay? The images you see in front of you are the RAM. We'll continue further on. Before we get to this diagram, we go through one more thing and then proceed further. The most important component in a computer is the processor. So now, as we just discussed, a computer is responsible for processing data. So for sure, we need something that will help us get that done. That device is known as the processor. So processor is responsible for processing or getting work done in that regards. Okay, ji? Okay. So generally, processor contains billions and billions of transistors that combine to form something. Like for example, you might have heard of having a, let's suppose, 2.0 gigahertz processor. We'll say it's a single core right now to make it simple. So this means because we have kilo, which is 10 to the power 3, then we have mega, which is 10 to the power 6, then we have giga, which is 10 to the power 9. So this means roughly it produces 10 billion instruction per second. So generally a single processor can get this much processing done. So in a computer, it's never about the processing. It's an issue. Rather, it's always the speed at which data transfers. That's one of the biggest bottlenecks in a computer. That's one of the biggest limitations in a computer. Fair. The first major type of processor is the CPU, known as the central processing unit. All we also call it as the microprocessor or even as the processor. The second is the GPU, which is the graphic card. Okay, so the CPU is used for daily applications that we do, running everything and doing everything in that regards. We'll be talking about that in a short while. Then we have the GPU, which is responsible for graphic related applications, like, for example, playing a heavy game or using a video editing software and image editing software to render images. The third category that you see over here is something that you might not have heard of before, known as the APU. APU is basically the accelerated processing unit. It's more of a combination of CPU and GPU performance together. So this is CPU that you see. This is a GPU or a graphic card. So with the APU, it's more of like combining CPU and GPU, both characteristics in a single chip known as the APU, which is the accelerated processing unit. Yeah. So that's the concept of APU. So it basically merges both performance to get a better outcome in a single chip. Sure, it has its own limitations. That's not a part of our debate because APU is not a part of our syllabus. We just discussed it because that's something that we practically use. Sure. Getting back to where we were, the diagram you see in front of you is a more complex working of how a computer works. I'll try and explain this of why do we have so many memories, what's happening, and so on and so forth. Let's start with part one. So the modern CPU that we see or modern processor is further divided into three parts: the ALU, the CU, and the MU. We have inspired, we as humans have inspired from how humans were created, and we have tried to use or replicate that in the computer as well. So the computer brain operates just like our brain does, ideally. Like we can memorize stuff, we can think, we can do multiple things together. Similar goes on with the normal computer processor. So it has the ALU, which is responsible for the processing part, which means it's the arithmetic and logic unit. Then we have the CU. The CU is the control unit. It controls the entire operations of the computer. Then we have the MU, the memory unit. So the computer has different types of memories. We'll get to that shortly. The CPU contains a short memory which holds the data immediately just while processing and then it moves forward. We'll get to that shortly. So as I just said, a computer contains multiple types of memories. The secondary storage, the RAM, the cache, the ROM, and then we have registers and we have buffers and so on and so forth. There's a billion different types of registers and memories in that regards. Why? Because the computer architecture was designed in such a manner. Fair. Getting on to the next part. For us, our concern at this point is कि structure कैसे काम करता है. I'll try and explain this. This is how a complex computer works in that regards. मैंने अभी समझाया था primary memory are those without which a computer cannot work. अब हम बात थोड़ी सी आगे बढ़ा रहे हैं because this is something that we'll discuss in chapter 3. But थोड़ी सी discussion अभी कर लेते हैं ताकि बात clear हो. So me and you, our data is never stored in the RAM or ROM or cache. Our data is permanently stored in the secondary storage. But it does have to go through this process. Here's how it works. Let's suppose data था A जिसको process करना था. A RAM में copy होगा, A cache में copy होगा, A CPU के पास जाएगा. It becomes information. Let's suppose this happens for a multiple number of data D तक आ गया. सबके लिए यही काम हो गया, सबके लिए चीजें स्टोर हो गई आपकी सेकेंडरी स्टोरेज. Now, what if I need to run A again? Here's what happens. Because the cache is one of the fastest memories in the computer, but yet it's one of the most expensive and one of the smallest memories in the computer. Typically, a cache is only 20 MB. Okay, it's one of the smallest computers, smallest storage rather in the computer. So why is it there? It's there to assist the CPU. क्योंकि CPU के पास डेटा फौरन प्रोसेस करने के लिए चाहिए होता है. अगर नहीं होगा तो उसको दोबारा रैम से लेके जाना पड़ेगा. रैम पे मिल जाएगा, ठीक है, वरना वो दोबारा हार्ड ड्राइव या एसएसडी के पास जाएगा. अब इसकी एक एग्जांपल देता हूँ इस चीज को जोड़ने के लिए. लेट्स सपोज आई वाज इन डी, मुझे दोबारा फाइल ए चलानी है. ना द सीपीयू विल आस्क द कैश फर्स्ट. कैश के पास तो नहीं है, वो रैम के पास जाएगा. अगर रैम के पास से डेटा मिल गया, वो उसको फैच करके ला के दे देगा, तो वो डायरेक्ट सीपीयू के पास चलेगी. तो इधर से ये जो डिले था ये डिले बच जाएगा. नहीं होगा तो दोबारा वहां से लाना पड़ेगा. I'll try and give you a practical example so that you understand that. When you open up the game on an application, any game, any application for the first time, let's suppose it takes 1 minute to load. The next time you open the same app, it will take 30 seconds to load because it has become a part of your RAM. अब हमारे एंड्रॉइड फोन्स में रैम को नॉर्मली कैश कहा जाता है. तो हमारा जब फोन स्लो हो रहा होता है, हम क्लियर कैश कर रहे होता है. एक्चुअली इट्स नॉट कैश. कैश इज अ वेरी स्मॉल मेमोरी इन दैट रिगार्ड्स. ओके, तो रैम का काम ये होता है वो डेटा होल्ड करके रखता है ताकि बार बार उसको प्रोसेस ना करना पड़े. इट्स मोर ऑफ लाइक बफरिंग अ वीडियो, स्टोरिंग इट, प्री फैचिंग इट, ताकि बार बार उसको यूज कर सके, मुझे दोबारा उसको लोड ना करना पड़े. आई होप दैट मेक्स सेंस. अगली बात करते हैं रैम रैंडम एक्सेस मेमोरी. हमारे पास जो स्टोरेजेस हैं, कुछ वॉलेटाइल है, कुछ नॉन वॉलेटाइल, एज इन टेम्पररी या परमानेंट है, डिपेंडिंग ऑन द नेचर. रैम इज अ टेम्पररी मेमोरी, पावर ऑफ होने पे डेटा चला जाता है. कैश देन अगेन इज अ टेम्पररी मेमोरी, वॉलेटाइल. ROM is a permanent storage. इसका मतलब है रीड ओनली मेमोरी. बट अभी एक थोड़ी सी लंबी डिबेट है, बट आई जस्ट start with a question and stop it over there. When you purchase a new phone, you see, especially with an Android phone, it says 256 GB ROM. But ROM means read only memory. So we cannot have 256 GB of ROM or a 1 TB of ROM. So the idea is when you buy a new phone, if you buy 256 GB ROM based phone, you can only access, let's suppose, 250 GB of data. इसका मतलब ये ROM का पार्ट नहीं है, इसके अंदर 6 GB है, सिर्फ वो ROM का पार्ट है, because that is not changeable. Generally ROM is fixed. Generally ROM is fixed. तो अब सवाल ये क्या है? It's a memory that contains two things. एक BIOS, basic input output system, या एक और नाम है इसका, तो कहते हैं firmware. Important instructions required for the system to boot up before the operating system kicks in. Before the Windows or Apple or whatever logo comes in, उससे पहले जितने काम करने होते हैं वो सब के सब ROM में इंस्टॉल हुआ हुआ होता है. So this is a bit about this diagram. This is how the computer works overall. I hope this is clear as well. Proceeding further. Next part of discussion is software. We just talked about it. Software is basically, so before we get to the software part, just to conclude, we just discussed a computer is based on hardware and software. Compatible होना दोनों का जरूरी है. Compatible meaning दोनों एक दूसरे को support करें. We just discussed if we have all of these, that device might be considered as a hardware. आगे बढ़ते हैं, हम सॉफ्टवेयर पे आते हैं. सॉफ्टवेयर के बारे में हमने बात की थी. Software are the virtual components of a computer. Virtual, something that does not physically exist. So, like the icons and everything you see in front of you, the screen is something that is virtual. I cannot drag them out of my screen, but I can use them using a hardware. Now, the two major categories of software, the system software or the OS and the application software. So, just go through this, I'll explain. System software कहते हैं those critical components that help the system run smoothly. It also overlooks after the functionality of how a computer will work and everything in that regards. OSB system software का दूसरा नाम है. These are important for the computer hardware to work or operate smoothly. Without this, we cannot work on anything in that regards. I'll give you an example. Hopefully, that will be understandable. Next is the application software or something that we know as apps. So everything, generally हम कहते हैं everything other than the system software or everything other than the operating system, something that's not critical, would be considered as application software or apps. इसीलिए App Store या Play Store पे there's multiple categories of what you can select out of it. अब एक example देता हूँ and we'll try and finish up this chapter 0 that we've been discussing so far. Hopefully it's clear. If you still feel you have any query in that regards, please do let me know even after the class. Yeah, let's proceed further. So the next part of discussion is, here's what we need to understand. Why is hardware and software both important for a computer? Why do they have to be compatible? इस पे बात करना शुरू करें. The user, that's me and you, we understand the high level language, something that we'll study in chapter 4. The hardware or the computer understands low level language, which is binary. मेरी और आपकी ज़बान इंग्लिश है, कंप्यूटर की ज़बान बाइनरी है. So it does not understand my language. So what happens? Both of them cannot communicate with each other. यहाँ तक सब clear? Proceed करते हैं. So what do we do? I'll give you an example. Let's take an example. Let's try and finish this up. If I want to print a document, I won't, as a user, talk to the printer directly. कि मुझे print करके दे दो. Because I cannot help the computer understand my language. That is someone's responsibility. That specifically is software's responsibility, and software can further be divided into two categories, the OS and the application. Now let's connect the entire thing. Part 1, we cannot follow this path because I cannot help the user and the hardware understand my language and vice versa. So what do? We have software. What's a software? Software, we just said, are the virtual components of a computer. Just to give you some idea, some reference, when you purchase a new device and you boot it up, the OS is already installed in it. In this case, it's Windows. For you, it might be your iOS. For someone, it might be the Mac OS or so on and so forth. So the first thing is you have your OS. And on that OS, we have the application software that we install. So one general definition for application software that we say is it helps increase the productivity of the user. I'll give you an example. If I ask you to design a banner or a poster, you will get that done. Let's suppose I ask you, you only have Paint, MS Paint, that's it. You can get it done. It won't be accurate, it won't be great because of the lack of tools and everything. But what if I give you Canva or some other software? You will get better work done in a smaller amount of time because you have better tools. So we have application software which are responsible for increasing the productivity of a computer or productivity of the task that a person does on a computer in that regard. So just to complete this example, if I as a user wanted to communicate with the printer, I'll first install Windows on the hardware, and on the Windows I'll install a certain PDF viewer. We'll open the document on it and we'll type in, for example, Control plus P to print the document. Once I do this, this will be converted into its equivalent values and sent to the operating system. And the computer understandable language will be sent based on that, and it will give me a print order. So this is how a computer works. Hence, compatible hardware and software needs to work together to get or produce a proper final result in that regards. Hopefully, this is clear. This is the conclusion of chapter 0. I do understand it was a bit accelerated, but the goal with this part of discussion was to keep in mind major concepts because these are some things that we'll be discussing in chapter 3, 4, and in through the entire syllabus. So you should be clear on all of these parts. Diagrams are an important way of understanding and remembering information because, as I pointed out earlier, they might be asked at any certain point of time. Hopefully, everything we've discussed is clear. We'll keep it up till here for now. We're done with chapter 0. Inshallah, we'll continue with chapter 1 in the next class. Hopefully, everything we discussed was clear. Thank you. Allah Hafiz.